100 participants have registered till yesterday, and from 26 countries. To begin the program, I would like to invite Mr. Virendra Bajracharya, Chief of Party, to deliver the opening remarks.
A very good afternoon to all the participants who are connected through online as well as who are here. It's my great pleasure to welcome Dan Orin and Astos Limai, with whom we have been partnering since 2010 under the SARVIR initiative, a joint initiative between NASA and USAID, mainly with the motto connecting space to village. How we can benefit the villages, the communities from the resources that we have coming from the satellites, the technologies and others. And over the course of last 13 years, this partnership has grown stronger and stronger, and also trying to make more and more relevant to the ground. At the same time, NASA also has come up with its own new strategy on NASA science to actions. So this is very much aligning with what we have been trying to do for last several decades. And also all the agencies are now coming closer to really make meaningful impact on the ground, which is also aligning very much with ICIMOD's own new strategy. We are all here to listen to Dan and Asta, so I won't be talking long. But again, I really want to welcome you all. And on top of that, I would also like to announce that we'll also be releasing launching one mobile app, which was again translation of our high impact weather assessment toolkit, which we developed last 8 years now. And we thought that with the mobile app, we'll be able to reach out to larger communities. So it has been there for a long time on the web application. And also we have got very good feedback on its performance. But again, really to benefit from these applications, mobile is the only means to go to the masses. And in this partnership, we value our collaboration with Red Cross, where they have also collaborated with us. The volunteers have helped us in terms of validating the results of our models and all those, which gives us more confidence in terms of going to the ground. So with this, I would like to welcome you all once again, and thank you.
Thank you, Mr. Bajracharya. Now, please allow me to introduce our key speakers for today, Daniel Arwin and Dr. Ashutosh Lime. Daniel is a research scientist at NASA Marshall Space Flight Center and the Global Program Manager for SARVIR, a flagship program of NASA and USAID, with activities across 50 countries throughout Eastern and Southern Africa, West Africa, Hindu Kush Himalaya, Southeast Asia, and Latin America. He has over 25 years of experience in satellite remote sensing applications and geographic information system in the developing world. He has served as a lead remote sensing specialist in support of NASA's space archaeology program with a focus on detecting structures of the ancient Maya. He received his master's degree in environmental science from Miami University in 1993. Our speaker, Ashutosh, is SARVIR Chief Scientist at NASA MSFC. He leads the SARVIR Applied Science team, which focuses on transitioning the applied research to meet the needs of SARVIR regions. Previously, he was involved in validation experiments for remotely sensed soil moisture from ground, airborne, and space-based microwave instruments. He received his PhD degree in 1998 in civil and environmental engineering from the Utah State University. The floor is yours, Dan and Ashutosh.
Wonderful. Thank you so much. It is great. How do we get to the switch to this one? Wonderful. Thank you so much. It's really an honor to be here back at ICIMOD. Thank you, ICIMOD, for hosting us, hosting multiple events this week. This is I think, one of the largest contingents of NASA employees we've ever had come over here at one time to ICIMOD. So it's really just a true pleasure to be here and to share what we're doing to connect space to village and this whole concept of Earth action and Earth science. So when most people think of NASA, they think of rockets, they think of astronauts, rovers on Mars, or even the new James Webb telescope, which is peering into the depths of space. But part of the beauty of space is it's also a unique vantage point where we can see our home planet. And almost since its inception in 1958, NASA has been studying the Earth. In fact, when NASA was founded, one of its initial goals was to study the Earth from space and use that information for improving our home planet. And one of the first examples of this occurred on December 24, on Christmas Eve of 1968, when astronaut Bill Anders took this extraordinary photo of our home planet from lunar orbit on Apollo 8, and considered probably one of the most influential images of all time. It transformed our entire attitude towards a world that we had previously taken for granted. And for the first time ever, we saw ourselves from a distance, and we could see the Earth in its surrounding dark emptiness. And it not only seemed infinitely beautiful, but it seemed infinitely fragile. And this really created this concept of spaceship Earth, and this notion that we are just this blue marble, this one planet with a very thin atmosphere in the darkness of space. And since then, NASA has created a constellation of Earth-observing satellites that are looking at our planet using different parts of the electromagnetic spectrum, looking at our planet in different ways, and what I like to say, collecting pioneering observations of our home planet, looking at our oceans, our atmosphere, our solid Earth, and bringing that information together in new and powerful ways to give us insights and information that we couldn't see previously. We can even see, and you probably have seen examples of this image before, we can see our planet at night and see the footprint, the massive footprint on our planet that humans have created. And we use this type of information to even find new communities and find new areas of deforestation, because sometimes we can see things differently when we look at them in different ways. Or we can look at fires. This is an older animation, and I do this on purpose because we're still seeing it today, but this has started since 2006. We started taking this information, looking at fires, and each red dot you see is a hotspot. This was taken from MODIS. We now have new satellites that are looking at information even more frequently than daily, but every 10 or 15 minutes, and you can see the massive fires that cross, for example, Africa, all the way from Ethiopia to Senegal, or in South America, or in Central America. And what's so important is that NASA, even though we started this in 1958, we continue to be adjusting and adapting to the current situation. As our leadership says, there are many, many challenges. We're all working hard to become resilient to climate change. We're all seeing the effects of a changing climate. But our leadership says we're not writing Earth's obituary, because we're all working together, and we're all trying to solve and address the major challenges that our planet faces. So we have a new Earth action strategy at NASA, where we're really working, the whole notion through the mission and vision is to take the applied and the applications and put it up front, and to say, you know, we've got the knowledge and the data and the Earth systems, but ultimately we're trying to get it to what are the real applications, what are the decisions and actions, and we're putting that first at NASA. So yes, the science is important, but it's ultimately about what are the decisions and actions that can be taken to address the challenges that we have in our planet, and to take that information and the feedback from communities such as yours. And that's why it's so important. We just had a phenomenal meeting beforehand with some colleagues from Bangladesh, some who are here, and to listen to the concerns and how can we bring that back into NASA, and how can we even potentially change future satellite missions to really address some of the issues and challenges and cares and concerns that countries around the world are facing. And that's what we call Earth Action, not this pillar where we have science, not this pillar where we have sort of action and applications, but bringing it all together and working together as a community to solve those. So going back, it was mentioned in the introduction how I got started in this field. I actually, before creating the SARVIR program, I supported what was called NASA's, or what is NASA's Space Archaeology program. And my job back then was using satellite data to find Maya sites, Maya archaeological sites that had been hidden under the jungle, under the vegetation for over 1,000 years. And we could use satellite data to actually peer through and look at the spectral signature and actually see many of these ancient cities, and then work with officials in the country of Guatemala to protect those sites, because looters were coming in and stealing artifacts from that site. So we wanted to see where all the sites were, and we used satellite data to actually detect that. In the middle, that's a younger version of myself with hair, but anyway, but it was really an amazing thing, and all the yellow that you can see, it's a little bit hard to see, are archaeological sites, and you can see examples of some of the sites. If you fly over in an airplane, it looks like hills, but when you use the satellite data, you can actually detect where those locations are. We made the front page of National Geographic, and currently there are massive activities in the country of Guatemala to help protect those sites that we've helped. But one of the challenges in the countries were saying, you know, it's great to look at your past, but how can we use that information for today? So this is one of the early images that we took where you could actually see a political boundary from space. In this case, it was the boundary between Mexico on the left and Guatemala in the green. And you could see that Mexico had completely deforested all of their trees, and Guatemala still had their forests intact. And that one image also made it into National Geographic, was directly responsible for one of the largest protected areas to be created in Central America. So one of the largest protected areas north of the Amazon. But one of the challenges that we were still seeing at NASA is that we had all this incredible science, and that we had needs and cares and concerns of end users. And we really felt that it was a bridge that needed to be connected. So I set out to develop the SARVIR program. And the SARVIR program is a collaboration between NASA, Space Agency, and the U.S. Agency for International Development, or USAID. So it's probably what I like to say the two most different yet complementary agencies in the United States federal government, because we work in space, we travel into space, and we use the unique vantage point of space to look back on our home planet, and USAID works in countries around the world, and it's to work together and collaborate with crucial key partners such as ICIMOD to co-develop solutions to address many of the issues that countries are facing in areas such as agriculture and food security, water security, ecosystem and carbon management, things like land cover and land use change, weather and climate resilience, and most recently, air quality and health. And this is what our network looks like, what the program looks like. In green are the countries that we work in. In orange, we actually have what we call SARVIR hubs. So we have SARVIR Amazonia, SARVIR West Africa, SARVIR Southeast Asia, SARVIR Central America is opening up within the next couple months. And of course, SARVIR Hindu Kush Himalaya, with a very strong collaboration from ICIMOD, with ICIMOD since 2010. To give you an example of the importance of this program, the NASA administrator came to cut the ribbon on SARVIR Hindu Kush Himalaya back in 2010. Charlie Bolden, who was commander of the space shuttle and launched the Hubble Space Telescope, and the administrator of NASA came here, really values the importance of this program. And what we do, we have This is sort of who we are. In the middle is the SARVIR network. We have NASA, USAID, our SARVIR partners, but the collaboration on the left with the private sector, bringing in data from private sector and collaboration, other government agencies in the United States, such as NOAA, USGS Forest Service, international organizations, World Food Program, the UNFAO, and of course, university researchers and collaborators. And then on the right is really the end users and beneficiaries, such as governments, private sectors, NGOs, and of course, the community and individual level. And our approach, we really try to be different because as a space agency, we want to be very careful that we're not just creating solutions and saying, we like the joke, we like a ball, we throw it over the fence, right? We don't want to do that. We want to make sure that everything we do is co-developed with our partners. And that's why it's so important to have partners like ICIMOD and the many government collaborators and university collaborators and NGOs that we work, that we're co-developing them. We're involving women and men and indigenous leadership in the service design and development process, that we focus on decisions and actions. Science is great, love science, I'm a scientist, but making sure that we're focusing on the why in those decisions and actions and ultimately measuring the impact. And we do this through, we have different mechanisms. We have a SARVIR Applied Sciences team. We bring together some of the best researchers and collaborators, many who have come here. In fact, we have one, Erin Nager is one of the Applied Sciences team members from NASA who is here giving a simultaneous training on air quality right now. And on the right is the SARVIR Science Coordination Office. That's a team that I lead at NASA that we help coordinate and collaborate and provide science support for the entire network. So right now, I'm going to hand it over to Ashutosh, who is the SARVIR Chief Scientist, to talk about some of the services, and then I'll come back and wrap things up.
I've done this many times. It's always a hard act to follow this guy, but I'll do my best. It's an honor to be here. Well, I put my thing in the pocket. It's an honor to be here. As Dan mentioned, so SARVIR started off with activities in the region, and then instead of doing these projects or one-off things and throwing it over the fence, quote unquote, we are exploring how we can be there with the partners as they encounter challenges. So instead of a once and done project, once and done tool development, we are now evolved into what we call as services, where we are there in the development phase and beyond for continued support. So as Dan mentioned, one of the training that is happening upstairs in the main building is the air quality. So ICIMOD has a strong air quality program. We are bringing newer satellite products, newer modeling capabilities, and we are helping add to the air quality watch that is a dashboard that is being built here. So the idea is to bring a 48-hour forecast to enable decisions made be. So right now there is a forest fire that is actively raging in Uttarakhand, if you have noticed. Where does it go? What is the trajectory? So we have some certain tools that we are looking to identify the trajectory of that and to explore what areas could be impacted. We have done this in similar stuff, not the same stuff, similar stuff in other parts of SARVIR network. So in Southeast Asia, we have developed a modeling and observational framework called as Air Quality Explorer. So it started off as the Mekong Air Quality Explorer. We are expanding beyond. It is a downscale global model which assimilates local data and produces a forecast that is actionable. So it produces a 3-day air quality forecast. Right now, we are in Thailand, and we have nearly finished developing it for the entire Southeast Asia, for the ASEAN region. So it is one thing for us to develop things with ADPC in this case, or ICIMOD in the case of the previous application. It's another for it to make it a starting point and make it a tool for others to take over and make it bigger, make it their own, make it more useful. So in this case, we have seen the Air Quality Explorer has now spawned off in newer applications, burn check app. So in northern Thailand, the government, the Thai Pollution Control Department, they had a difficult time managing the prescribed burns for agriculture. And so, based off of this forecast, now they are issuing a much tighter window. Next 3 days seem like a bad time to burn. So in the olden times, they would say 2 month window you should not burn. Well, that's not practical. That's agricultural practice. People basically ignored it. But now we all are feeling the bad effects of air quality. So we are working on trying to do what we can. So people, all of us, want to do the best that we can. But these inactionable or just in the warnings that are not actionable are not useful for us to act to decide our agriculture practices. So this burn check app has been really vital, and we have seen the PCD has seen substantial drop in agricultural burns when they said don't burn next 2 days. So those are the kinds of things that we have developed an app in collaboration with Thai Pollution Control Department, and now this is their own app that is going beyond, and it doesn't stop there. So the smoke watch or the burn check app, it has spawned a different kind of clientele that is starting to use it. Private companies or large corporations. Now PTT is using those forecast apps to advise people to whether travel or not travel. Bangkok has one of the worst air qualities in the world, and they are using this information to advise their employees to not travel. Pregnant women, just a couple of weeks ago, they had a ban or the recommendation not for pregnant employees not to come to work and work remotely. So those are some actionable things that you can do when we work together. Similarly, so in food security and agriculture, when unexpected flooding destroyed agricultural crops, ICIMOD, with all satellite data sets, developed the crop area map in really record amount of time, in 2 days. Typically, it would have taken much longer to use satellite data sets and delineate. But because ICIMOD had the ability to quickly react, it had the ability to enable distribution of a large sum of money for the affected people. So in East Africa, we are looking at using the remotely sensed information to enable insurance. So that is one area that is critical. There is only so much we can do. There is a full industry that is capable of taking advantage of this forecast if data is available. And so so we took it upon ourselves to make these kinds of data sets accessible to all private companies. We are not identifying individual companies to benefit for their particular benefit, but this data set is available to all. And so certain companies government and some private entities have taken this and now started creating their own insurance program. So in this case, the Kenyan government, in collaboration with World Bank, they have an agricultural incentive program where it's an index-based insurance. So people have to buy in, and then so if certain section has drought, then they would get payoff. So this has been very successful and is entirely run by government of Kenya now. So our aim is our job is to get out of job. We don't want to keep doing the same thing over and over. We use satellite data sets, we use modeling products, we enable people to use it and then walk away. We are there if they need us for support, but our job is to just leave and let them manage it on their own. Because that way we can do bigger, better things. And we have found that to be the best way to enable science to help society. So in West Africa, we have another unique challenge where pastoralists' traditional knowledge is falling short. The rainfall patterns are erratic. Where it used to rain and fill up some ephemeral ponds that would evaporate at the end of the season would have water. So certain old traditional knowledges where the pastoralist would expect to go to a certain point or certain pond, there would be water in the past, no more. So veterinarians without borders. So as Dan mentioned, so we are engaging our users to see what their needs are. So with that, so we learned that veterinarians without border, they said, well, these pastoralists call us if they have problem with their herd, but now they're also saying, now that my cattle is hurting, where can I take her for water? The place that I normally used to take doesn't have water. So they just mentioned it in almost in passing. And we said, well, satellite data sets, if anything, especially in the desert area, it is really straightforward to estimate available water body. It is a little more complicated than that. It turned out to be a little more complicated because in this desert area where there is water and these ponds is also where vegetation grows. So that complicated a little. But we have figured out a methodology to use real-time operational satellites and the data from it to produce an app that can easily tell if a particular pond has water or not. And then in the process, we have identified a lot more ponds that have water as well. And that has enabled these pastoralists to cope up with with this climate change, and has enabled them to be resilient. GeoGlows, so GeoGlows is a ECMWF streamflow forecasting service. So we are using European streamflow data sets using certain routing scheme, which I won't bore you to death. It started right here in ICIMOD. Back in 2015, 2016, we started using the streamflow prediction tool, SPT. You've seen it in certain apps that you might have seen come across at ICIMOD. And now it has caught on like a wildfire. And now it has gone global. World Bank has enabled ECMWF to keep producing this because of the success here in this part of the world. World Bank has enabled this to be created operationally at ECMWF. So we don't have to keep, again, we want to be out of the job. They are doing this on their own, and we are just using the data that they produce. So this now the newer version is allowing 11.5 million streams throughout the world. It produces a stream flow forecast, ensemble-based stream flow forecast, 15 days in advance, and it's quickly becoming a very popular service. And the good thing is it is owned, quote unquote, owned by as many people. World Bank claims it's theirs. We claim it is ours. ECMWF claims is there. It's a good thing. You want people to own you so that they become your champions. And ultimately, if the point is to enable this data to be used in decision making, holding it makes it worse. Letting people own it helps it only grow bigger. So I don't have time to talk about certain slides, but in Nepal, a couple of years ago, we had some training right here actually about a streamflow prediction tool, and a farmer and a school teacher happened to be in attendance. He actually went back, kept monitoring the website for a forecast to see if it's going above a certain limit for the river for a stream that his village had, and he noticed a sharp increase a few days later. So he convinced he convinced there was in the river channel itself, they had a cement plant, which was a major source of income for the town. And so he asked the community leaders to act and clear up some of the debris that was hindering the flow. They did that. The flood did come, and it was such a success story that the power of information was very obvious. There are other cases in Ecuador. We are enabling the similar SPT, streamflow prediction tool, or GeoGlows has enabled irrigation systems to be designed because they didn't know what the low flow was, and this tool allowed them to estimate stream flow going back 30 years. In Malawi, this system was used to identify a forecast for a different part of a county. And they had, in collaboration between two SARVIR hubs, ICIMOD and RCMRD, two of the SARVIR hubs, they worked together to install some early warning systems that help save lives and property. So this GeoGlows is becoming a fast used tool to improve decisions in around the world. So in Southeast Asia, a protected area is getting threatened, like most of the places. And so SARVIR is using satellite radar information, which can see through the clouds and through the vegetation, to see what areas are getting impacted. So Cambodia has significant amount of cloud cover. So optical data, the ones that we see, we can see as if you take a picture, you see a picture of cloud from space, but there are certain other wavelengths, certain other parts of the electromagnetic spectrum you can see through the clouds. And now they're using this radar-based methodology, using some European data and some NASA data to develop a system for real-time assessment of deforestation threats. And that has helped issue warnings and arrest or stop the illegal deforestation. That is something that has been really rewarding for us to see that, drought resilience. Mekong River Commission has used Southeast Asia's nowcast using seasonal subseasonal forecast. Nepal Agricultural Drought Watch right here in Kathmandu address much needed drought preparedness, monitoring and forecasting using seasonal subseasonal forecasts. So the idea is to take these global models and make them usable at the local scale, such as the forecast for drought characterization. Severe weather, that's another hotly challenging, a huge challenge for this part of the world and many other parts of the world. So we are helping, so ICIMOD and SARVIR Global, we put together a ensemble modeling system, working collaboratively with DHM here, as well as Bangladesh Met Department, to put together this system that is allowing a probabilistic assessment of lightning, thunderstorm, and hail, the three things that are most devastating to the farmers. And now those BMD forecasts are being done on their own cluster at BMD, and they're enhancing it with a new World Bank grant that they received, and the machine is almost ready. So, but that's not all. Those are, as I said earlier, those are some of the things that we do. But now they're finding it more and more applications. So DAE is exploring how, or we had conversations with DAE, how this data set could be of value to issue alerts in their own capacity to protect agriculture in Bangladesh. So in short, the services that SARVIR are working on are locally led, we are needs driven, collaborative, inclusive, and most importantly, built to last. Our job is to get out of job so that somebody else can own this, continue using this going forward. With that, I'll hand it over to Dan.
Right. Thank you so much, Ashutosh. And I just wanted to wrap up with some distinctive aspects of the SARVIR program. First of all, is the power and depth of the SARVIR network. So when the SARVIR program started, we were just one hub, and now we've grown into this global network. And this is one of the times we got together back in 2020, right before the pandemic. We typically get together every year. We're getting together again this year, but just an incredible community of people from dozens of countries around the world. Overall, the SARVIR program, we probably have some 500 people that support the SARVIR program overall. Also, really our approach. We have, on the left, we have what we call our SARVIR Service Planning Toolkit, and that is available online. You could Google that, but it's basically our recipe book of how we work through and how we develop our services. And, it shows the different steps and the types of questions that we want to ask. Also, what is crucial to NASA, ICIMOD as well, with their open data policies, but this whole notion of open source science. We're no longer in the world where, that science, data is not shared, code is not shared. We want to make sure that the products and services that we create are open. We understand and respect data policies from partner groups, and we respect those. But our whole notion is open data and open science, and also this notion of scaling and replicating. So Ashutosh talked a little bit about this, but the fact that we have this network and the fact that we have open science means that code and information and ideas generated in one part of the world can be shared in other parts. And Ashutosh talked about on the right the streamflow prediction tool, or now GeoGlows, was created right here with ICIMOD and is a global service used around the world. We have other examples like gold mining. Illegal gold mining is a problem in West Africa, and it's also a problem in the Amazon rainforest. And these two hubs are working together, have worked together to create a common service, sharing their code back and forth. Also, what's crucial in the SARVIR program, and ICIMOD is a lead in this, but working on gender inclusion and the notion of supporting women leaders and gender champions in the SARVIR program, empowering women and girls to explore STEM fields. ICIMOD has done remarkable work here. In West Africa, we even have SARVIR clubs where girls participate in those clubs and learn about science and STEM. Integrating gender considerations into the service development and design. So we look at who's using the data, how they're using it, and what are those gender considerations. And of course, looking at different groups and making sure that we're taking all groups into consideration. And finally, really what we've learned, SARVIR is going to turn 20 in next year. And some of the things we've learned is the importance of sustained relationships. Most projects are 3 years. We are so lucky that we have a program that's been around 19 years. We have a relationship with ICIMOD almost 15 years, and having those sustained relationships, because science evolves, problems evolve, and the fact that we can continue working together, and I can't emphasize enough that it's a two-way street of information flow. The truth of the matter is we learn more from our ICIMOD colleagues probably than anybody, and when we share information and data back and forth. And this notion of co-development, that if we're working with a government agency or an end user beneficiary, that they are part of the design and development process, and we document that and we talk about that in the service planning toolkit. The fact that our products and services, and we have, Ashutosh showed a few, we have over 50 services, active services, that they're demand driven. That it's not this notion of, hey, I have a really good idea, why don't I create something? But we listen and work and conduct user needs assessments with the communities and try to develop services based on that. Also locally led. The importance of we're working with organizations, in region, local organizations, and regional organizations as well, but really ensuring that the activities are locally led. Open science, I talked about it. Absolutely crucial. We continue as NASA to try to push the field forward in that. Sometimes we have pushback. People say, no, it's my data, it's my code. But we believe in this field of Earth action and Earth science, it's so important that the information is open. Good communication, we're always still learning that, but we try to communicate amongst each other and really share and have good stories. And a really good comms team. Again, ICIMOD has helped the network with really good communication. And to me, the most important thing has been interdisciplinary teams. It sounds cliche to talk about this, but every problem that we solve, we want to make sure that we have not just scientists and researchers, but social scientists. And I mean, we've had artists on our projects and that just do phenomenal work, and communications experts, and so many people from different perspectives and different views that truly make the work and the programs that we do more successful. So thank you so much for your time. It's been almost a 20-year journey of how we are working to connect space to village, how we're, really, I think as the planet, as we have greater challenges, we have to work together as a global community in new and different ways, using new tools, working in different ways to really address the challenges and become more resilient in a changing climate. Thank you very much. And I think we have time for questions, or? Yep, okay, great. I'll share the microphone with you.
Yeah, the floor is now open for question and answer.
Please.
My name is Bhola Gimire. I am from Institute of Engineering. My question goes to Ashutosh, I think, about the air quality. Yes, every day you are mapping different air quality and which is in the not good conditions in this earth. And what is the main reason for it and how you will be controlled? Because in early few 2 decades ago also, while I was child, at that time also I used to hear news about in Amazon forest, there was the firing, 57 days, 3 months, still it was not controlled because there was also the pollution. Nowadays also it might be controlled a little bit and you have the new technology also. Only showing the bad things and just giving kindness to the human beings. What you want to control. The control is major thing than that of the showing the main actions. Okay.
Yeah, that is such an important point. Um, having the ability to monitor what is happening is the first step. What can we do about it? There are things. I mean, if we have not evolved to a point where we could eliminate the forest fire in Uttarakhand today. That the technology doesn't exist. Few 100,000 hectares burning. We cannot just put it out like this. I wish we could, but we are not there. So what is the next best that we can do is to see where this is going and to reduce the impact of those on the people. So in SARVIR or in several similar programs, the aim is to connect with the needs of people and to identify how to minimize the impact, the bad impacts on our populations. So that's why we are looking at trajectory modeling like high split, and there are several models out there. We do have one that is being worked as we speak here on estimating where that plume is going to go so that we can have a better warning for people to stay indoors if the air quality goes above a certain limit. And to minimize the impact, reduce the number of hospitalizations and ultimately death. So yes, we cannot reduce, but having that awareness of where this is going helps us protect us in the big picture. Does that help?
Hello, this is Arif Hassan Khan Robin from Bangladesh Agriculture University. So two things, I am very impressed and happy to hear from that the NASA is now connecting to space from space to villages and working for the whole world and trying to mitigate and adapt the climate changes issues throughout the globe. So my question is, being a disadvantaged country like Bangladesh, and there are new challenges that are evolving, like heat stress, flood, and many other issues. So how can we work together and can cope these challenges? First thing. Second thing is carbon in one corner of the world and some maybe throughout the world, carbon emission is happening the faster way, and we are talking about the deforestation and plantation. So which one is more important, reducing the carbon emission or the just the transplantation of the trees? Thank you.
Yeah, I'll take the easy question, the first one, and give the harder one to Ashutosh. But no, I mean, I think thank you for your comment, and I think one of the important things are, I mean, first of all, I'm so glad that we had the chance to meet and we had the session before lunch and to really understand some of those concerns, even in the conversation that we had, which we just had a couple hours together, and we were talking over lunch amongst ourselves that there's incredible synergies with you and the work that you're doing through the university, and it's. I do think, I mean, as much as the technology of Microsoft Teams and Google Meet and all of this have helped us in so many ways, it's the being together and sharing, and sharing the time together has been just crucial. So we could listen and hear some of the issues that you had. So we got inspired, and we're going to continue the conversation with you afterwards. So I think it's listening carefully to the needs. And I want to thank ICIMOD for always creating the enabling environment for that, like the forum beforehand. So I think that's one example of it, and we look forward to continued collaboration. Now the hard question. He's had time to think about it, so.
Thank you. Thank you. So flooding is, as you know, climate change is increasing the variability of rainfall, and that is creating all these problems. There is torrential rains and the problems that come with it, and then lack of rain, cracking up soil and the problems that come with it. And we are seeing more of these extreme more frequently. And so that is a global challenge. How do we deal with it? Again, having awareness is one thing, the first thing. So we used to have a colleague who used to come here very regularly, Lee Ellenberg. So he was he came from an agricultural family. And so he has now leading, he's left SARVIR, and now he's leading a new initiative in the state where we live, Alabama, where we are taking the money from, or he begged, borrowed, stolen some money from some other federal agency to create some small ponds on the field, on individual farmers. And the idea was the farmers donate time. Half of it is their own time, half of it is compensated by the government. So there was some specific way they operated. So government is subsidizing constructing a small pond on their farm. The benefit of it is they have a little bit of water, not a lot of water, but they have a little bit of water that they could use when the rains don't come. And instead of having a complete crop failure, you have at least you're just above the water, you can still keep breathing. And those are the kinds of solutions that are critical for us to better respond to this changing climate. So while we really were sad to see him leave our program, we are really proud of the work that he's doing, that is pioneering, and we are hoping how that can be scaled up. Carbon dioxide, that is, your answer is as good as mine. Which is more important? I mean, these are important challenges that we as population at large, we need to tackle it together. And I believe we can. If there is a will, that we can find ways. We've done great things in the past. As a society, we have done great things in the past. I do not have any doubt that we will continue to find ways to find solutions. Electric vehicles are here. Is it a complete solution? No. Is it going to help us solve the problems? Yes. It's only going to go, we are going in the right direction. Economics is working out in a way that will help us. But I truly believe we can we can walk and talk at the same time. So challenging these disasters like droughts and floods and controlling carbon dioxide or managing the deforestation, we could do at the same time.
Thank you. Well, at first, thank you, Dan and Ashutosh, for this wonderful presentation. It was very useful, at least for me. I work here at ICIMOD. So I saw one slide where there was I mean, NASA, including, I mean, USAID, ICIMOD, all the organizations that that help in developing products and services. And then there was end users. So my question to you is, from your experiences or from your standpoint, what challenges do you see on end user side in terms of accessing and using those products and services developed by you in general?
No, that's a great question. I mean, I would say that it is so important in end user engagement to get very crisp and very specific of what the requirements are, and being honest with ourselves from our side, from the SARVIR side, can we address them and can we not? And if we can, what part of it can we address? And not recognizing, or recognizing, I should say, that what we, in some cases, may be providing a full solution. In other cases, we may be